recording of 3 to 1 model. Okay, what is the date?
25.
25, oh yes. 253 45 01 44 36 this is practical batch. Okay. 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 11:32. 11:10. This time we have less time actually. First 30 minutes theory, 20 minutes quiz, then 1 hour for practical and viva. That's it. No one will say anything. So today's topic, we discuss two tests simultaneously. I know one boring thing and one new thing. Okay, TIBC and TIBC. Okay, can anyone say what is the full form of TIBC?
Total iron
binding capacity test. So first let us see what is TIBC. No, I recall. What is normal vital cell count?
4,000 to 11.
Normal count?
4,000 to 11.
4,000 to
11,000
cells per
cubic
meter
of blood.
Blood, right? Per cubic millimeter. Then yes, where we will count the WBC?
In depth of pneumatic.
The pneumatic chamber, yes, in the four large corner squares. 4 large corner squares we will count this one. What is the depth of pneumatic chamber?
0.1 millimeter.
0.1 millimeter in depth. Very good. What is the diluting fluid?
The Hame fluid.
Turks fluid, okay, don't get confused. What Turks will do? It will preserve WBC, whereas destroy the RBC. This you know. Very good. Then what is the dilution factor?
So 1:20.
1:20. 20. Very good. What is the calculation, final calculation value?
N into 50. 50.
Okay, N into 50. Very good. Then that's it. So then what else we need to discuss? Methods of performing. So methods of TIBC estimation. What are the methods we have? We have manual method and automatic method. Automatic can be semi-automatic or fully automatic, that you already know. Semi-automatic or fully automatic method. Then manual method we have 2 types. Can you tell me the 2 manual methods? Yeah. This is a micro-dilution method. Okay, please don't forget here. Micro-dilution method and macro-dilution method. So what is the process of micro-dilution method? In micro-dilution method, we have a specialized pipette. So this pipette has the following things. So the pipette bottom mark is 0.5. Then top marking will be for WBC 11. Okay. For RBC, this will be 101. Okay, keep in mind. So what we are going to do? First, we will draw blood up to 0.5. Then we will draw what fluid? Turks fluid until mark 11. Okay, until 11th mark, we will take the. Are you fine, Miss Rejoice? Fall down. Okay, sit there. Okay, so mix the sample properly. Right? Then you will do it. The problem with this method is you need to do mouth pipetting. So mouth pipetting we are not encouraging it. At least I won't encourage. So rather than we are trying to do a micro pipetting method. Okay? Micro pipetting means here we are using micro pipette. Keep in mind, since we are using micro pipette, that doesn't mean method is micro method. That will be a macro method. Okay? Macro dilution method. Macro dilution method, keep in mind how we are doing it. Okay, so what is the macro dilution method? Very simple. You will take a test tube, you will add 4 ml of Turks fluid, then you will remove 20 microliters of Turks fluid from the test tube, then you will add 20 microliters of blood sample, a drop of blood to it. You will mix it properly, then you will go for counting. Right? You will charge the pneumatic chamber, then you will count in the pneumatic chamber. Is it clear? Now the important parameter is proper mixing. When you are not mixing the blood sample in the diluent, when you didn't mix it properly, what happens to the results? When you are not mixing properly, what happens? You will get a low values. Obviously you will get a error, you will get low values because the cells might be, sedimented at the bottom. You didn't mix it properly. So you took normal fluid and you are counting and you will get less values. So you need to properly mix the sample. Homogenization. Okay? You need to evenly mix the sample. Then only we can apply. Actually, that even distribution is the primary principle of counting these cells in the Newborn chamber. Once the cells are properly distributed in one particular area, we are estimating how many cells present in this area into the large area. Or in a nutshell, a drop of blood value will give you the value of your 5 liters of blood. Okay, so we are doing the statistical methods, and that needs an important parameter, that is proper mixing. Only when you mix properly, you will get proper results. It looks simple, but it plays a vital role. Is it clear? Any more doubts? No doubts, right? Yeah. In what X you will count the cells in microscope? Oil immersion, 100x, 40x, 10x, 5x. You should use 40x, okay? And never use 100x at any cost. 100x is only for oil immersion, okay? When you are keeping some Siddharth oil and you are going for DLC, only during DLC we will go with 100x, okay? Whenever there is a cover slip, we won't perform 100x, right? Cover slip containing test will be performed at 40x only, not at 100x. Please keep in mind. Okay, please don't damage the microscopes. I have seen some students who used cover slips at 100x and the slide has been broken, lens has been damaged, many things happen. Anyway, TWBC is clear, right? Then today we will discuss the actual first experiment in this semester, that is total iron binding capacity test. So what is this test and what this test is not? I want to be clear. What we understood here, this is total iron binding capacity test. Are we measuring iron in this test? Keep in mind, we are not measuring iron. We are not going to measure how much iron present in the body. We are measuring how much iron can be binded to the protein. We are more concerned with iron binding status, not the iron content in the body. Have you understood? I will tell more clearly. Listen. See students, in the body, whenever you are taking an iron dye, in the nature, iron is present in ferrous form. That means Fe3 plus form. Ferrous form. Ferrous form. When you took a dye, that is in ferrous form. Iron is in I3 form. Okay, Fe3 plus. Now this iron entered into the digestive tract, right? So this is the digestive tract. Now this iron will be absorbed into the circulation. This absorption is mediated by a protein, by a transferring protein. That protein is called as ferritin. Ferritin. The protein is called as ferritin. Okay? It is the ferritin that is transporting iron from the digestive tract to the circulation. Is this clear?
Yes, sir.
So listen now. If we have less ferritin, what will be the iron levels? They will be less. The levels of ferritin will give the actual status of the iron consumption in the body. Less ferritin, less iron. Is it clear? Because it is the ferritin that is carrying the iron in the body. Now, there are some interesting facts about iron metabolism in the body. Really interesting. Iron metabolism. I'm just discussing iron metabolism. Okay. The problem with the human, not only human, mammalian metabolism is we don't have a natural mechanism of excreting iron from our body. We don't know how to excrete iron from the body. We don't know how to eliminate iron from the body. Usually we can eliminate bilirubin. Many toxic products will be eliminated or excreted by urine or by sweat or by evaporation, right? But we don't have a mechanism of excreting iron. That is a very problematic condition. Keep in mind, when we are not excreting the iron, what happens? Iron will start accumulating in the body. Iron will be deposited in the body and that will cause an iron toxicity. Iron toxicity, okay, leading to death. What type of death you will get during iron toxicity? Iron will bind with the neurotransmitters. Okay. So wherever there is neuronal functions, those neurons cannot work properly. Now you can understand the consequences. Neurons in the heart, neurons of muscles, neurons of the brain, your vision, photoreceptors in the eyes, everything is neuron based. When we are not removing iron from the body, okay, that will cause this iron will be deposited in the tissue cell and the patient will die. Okay, so we need to transfer this iron to the bone marrow by ferritin. Ferritin will transfer this iron molecule to the bone marrow. Okay, in the bone marrow, this iron will be rightly utilized. This iron will be properly utilized by binding it with the hemoglobin. Iron in the hemoglobin is okay. Other than iron, other than hemoglobin is dangerous. Understood? Iron binding with protein is a safe form. Iron not binding with protein is a dangerous form. Is it clear, students? Is my concept clear? Iron in the presence of a protein is okay. A free iron in the body is a dangerous form that can kill you. Is it clear? Now we are going to focus on ferritin. Okay, let us see the ferritin thing here. Listen, when there is a less ferritin, what will be the iron status in the body?
Lesser.
Now listen carefully. When there is less ferritin, there is a chance of iron overload in the normal circulation. I will give you one example. Iron is in two forms, students. Bounded iron, unbounded iron. Bounded iron is the iron with protein, and unbounded iron will be a dangerous thing. This is not dangerous. This is not dangerous. This is safe, but this is dangerous. Is it clear? Iron with protein is safe. Free iron is dangerous. And the protein is our transferrin. Let us assume the protein is less in the body. What happens to the iron now? More iron will be present. Unbounded iron will be more, and that can cause a death. Is it clear? I will give one example here. Still. Now let us see a point from transferrin. Okay, transferrin point of view. Transferrin point of view. Okay, so we know that transferrin molecule will bind with two iron molecules. A transferrin protein will bind with two iron molecules. Okay, such transferrin molecule is called as saturated transferrin. Saturated transferrin means here the transferrin has been saturated. That means binded with iron. And other part of transferrin, they are simply floating in the circulation. They didn't bind it with iron. This is unbounded transferrin. Okay, we need to measure how. The idea of this test is how much maximum amount of iron a transferrin can bind. Both bound portion and unbound portion. I was trying to calculate the levels of transferrin in the body, and transferrin is in two states, bound state and unbound state. I need to measure both bound and unbound, which will give me the TIBC value. Total iron binding capacity of transferrin. I need to study the total iron binding capacity of the transferrin. This is the idea of the test. Why I am studying total binding capacity? Sometimes there will be a chances where there is a chance of more iron overload, and that will be transferred back by transferrin levels. When the transferrin itself is very less, the iron will cause toxicity. That means increased TIBC. I am giving two conditions: increased TIBC and decreased TIBC. In what conditions TIBC will be increased?
Less protein.
Yes. Guess, students?
Less protein.
In what condition TIBC will be increased? TIBC, that means Here, this protein is excessive. Okay, listen. Let us focus on this protein. Okay, unsaturated protein. Okay, unsaturated protein. Let us see. TIBC will be increased in case of some iron deficiency. During some iron deficiency, the iron is less in the body, so the TIBC levels looks more. The protein levels looks more. During there is no diet itself, there is no iron diet in the body, so on the ratio between iron and transferrin, this transferrin looks more. So increased TIBC is seen in iron deficiency. That means nutritional or some iron deficiency leads to an increased TIBC value. Is it clear? Increased TIBC value indicates iron deficiency conditions. Okay? And it is also seen in pregnancy. Okay, pregnant woman, she has diet of two persons actually. The fetus will take most of the nutrients. So obviously, increased TIBC is seen in iron deficiency and pregnancy. Okay, then decreased TIBC value. In what condition TIBC will be less? Let us see here. TIBC will be less in what condition? The binding capacity has been reduced. In what condition the binding capacity will reduce? Maybe there is too much overload by iron molecules. Because of this huge iron molecules, the number of transferrins might be reduced. Or the maximum amount of transferrins are already binded because of ongoing iron stress, and that resulted in decreased TIBC value. Is it clear? There is a huge stress of iron in the body. Somehow, some excessive iron is generated, and that excessive iron must TIBC already binded with that iron. So the overall TIBC value looks small because already most of the TIBC has been utilized by ongoing stress, ongoing hemolysis maybe hemolysis happening in the body. Hemolysis caused lysis of HB. Lysis of HB resulted in more iron molecules, and this more iron molecules has been already binded with the transferrin. So in this condition, when we are measuring the TIBC values looks less. When there is a ongoing hemolysis, when there is a huge iron stress means iron has been generated, maybe due to hemolysis, maybe due to other conditions. Polycythemia. What is polycythemia? Increased RBC count is called as polycythemia. Even during polycythemia, what will be the value of TIBC in polycythemia? More cells.
More
So,
HB. Sir, more HB होगा तो.
More protein will be there, no, in polycythemia.
So more H cells, more HB. More.
Yeah, more HB. So in polycythemia, I assume the levels will be more. TIBC levels will be more in polycythemia. Let me cross verify. So how we are going to measure this test? Okay. So for example, decreased TIBC is seen in hemolytic anemias. Give me examples of hemolytic anemias. Thalassemia, sickle cell anemia, sideroblastic anemia, spherocytosis, all the anemias that are hemolyzed anemias. Okay. In hemolytic anemia, TIBC will be less. Is it clear?
Yes, sir.
So how we are going to detect this test? In this test, we are trying to check two types of iron molecules. Serum iron, okay, serum iron molecules and unbound iron molecules. Unbound iron molecules. I won't write unbound. We'll see here. I will show you a diagram. Listen. So, yes, get inside. So I'm going to perform TIBC test here. Total iron binding capacity test. I'm going to perform TIBC. I want to evaluate the total iron binding capacity in the body. I know that in the patient serum, I have transferring molecules. Right? And I know that some of these transferrin molecules are already binded with some iron molecules. Okay, this is in two forms. A binded transferrin and non-binded transferrin. I need to measure both the forms, right, in the circulation. Am I correct? I need to measure both iron binded with transferrin and iron without binding with transferrin. Is it clear?
Yes, sir.
So what I will do is, first I will measure the serum transferrin, serum iron. How much iron present in a serum? First, okay. First measurement will be serum iron. That is the bound iron. I got the serum iron value. Okay. Serum iron value is around 10. Let us assume. Okay. Next, what I am going to do is, I will add a reagent, maybe some acid. Now I am going to add an acid to my sample. What this acid will do is, this acid will remove all the iron molecules from the sample. All the iron will be removed from the sample. So the entire sample becomes 0. The entire iron present in the sample becomes 0. Is it clear? First, I measure the present, how much iron already binded to the serum. I got this value. Then I added an acid and removed all the iron molecules from the sample. Is it clear?
Yes,
Why
sir.
I removed all the iron molecules? Now I will let you know. Now listen. The next step will be, I will add a known quantity of iron molecules to this test tube. I will add a known quantity of iron molecules. I will give you an example. The known quantity is 200. I already know how many iron molecules I am adding. I added 200 molecules to the test. Okay, I added known. Then what I did, I incubated for 10 minutes. In this 10 minutes, all the transferrin molecules has been completely saturated with iron molecules. All my transferrin molecules has been completely saturated, completely binded with my iron. Okay, after binding, some of the iron molecules will left over, right? Some iron molecules will be left over. I will do a centrifugation. After centrifuging, I will get a supernatant and a sediment. This supernatant I will discard. Then I will take the sediment value. I got sediment value is 150. What is this 150 indicates now? Total iron binding capacity. 150 minus my original value. I know I added 200. Okay, 200 minus 150. This 150 is the total iron binding capacity of my patient. Why we are doing iron capacity rather than measuring iron? The reason is, iron is everywhere in the body. Iron will cause toxicity. I want to check whether this iron has been properly transferred back into the utilization or not. The transferring is done by transferrin molecule, okay, a ferritin molecule, and I am checking ferritin's iron binding capacity. So this is an indirect test actually. We are using iron molecules to indirectly measure the ferritin levels in the serum. But my point,
Yes.
is the concept clear now? If you follow from one A to Z, then you will understand. Why we measure this one first, serum iron. First of all, I saw whether he has any functional activity or not. Whether this is just a serum iron test. This serum iron is nothing to related with the binding capacity. I'm just saying how much, this will give me the deficiency status. Actually, how much iron the patient can able to, his initial condition. In a patient, how much iron present in the serum, then I'm going with the total. Now you guys me another question. Really, I need to pause there. Why we are measuring serum? Initial condition of the saturated, in the initial condition, how much transferrin has been saturated in the body. Out of total transferrin, what portion of the transferrin has been binded and what portion has not binded. That value I will get by this test. Then the rest of the portion I will get by this value. That means this value minus this value. This is the functional status and this is the for 140 will be the maximum capacity. Okay, 140 will be the unbound capacity and 10 is the utilizing capacity of the body. Got my point? Now, increase the TIBC. Write down the normal values of serum iron. Serum iron will be around 45 to 75. The serum iron value is 45 to 160. These values are measured in micrograms per deciliter. Please keep in mind. This is micrograms per deciliter. Okay? This is for males. Male value is this one. Whereas females, the value is 35 to 145 micrograms per deciliter. So why there is a difference? The volume of blood. In males, volume is slightly higher than females. So less volume, less values, more blood volume, more values. Okay? Then total iron binding capacity. The total iron binding capacity of this normal range is 250 to 400 micrograms per deciliter.
Males?
250 to
Males?
No, this is a normal range. Average range for both males and females. The average range of TIBC is 250 to 400 micrograms per deciliter. Okay? Yes.
Can you please repeat that?
Yes, sir.
This test.
Then what is the normal value of unsaturated?
Unsaturated transferrin. Unsaturated. That unsaturated is already came. This is unsaturated. This value is unsaturated. So total value minus iron value will be an unsaturated value. Got it? Total iron value minus iron value. Serum iron value will give us unsaturated value. Unsaturated transferrin value. That's it, right? Total binding capacity minus initially how much binded will give us the unsaturated transferrin value. If you want to calculate unsaturated transferrin value, then you will minus the total from the initial iron binding thing. How much transferrin binded to the iron. This is giving the saturated transferrin status, unsaturated transferrin status. So now keep asking to explain everything in a simple Keshav how. For example, okay, I don't know how many hands the Keshav have. I want to estimate the Keshav hands indirectly. Okay, so how many hands he have is our problem. That is total iron binding capacity. Okay, total iron binding capacity means how many hands he has. So what I will do is in this test, first very large simple thing. If he has two hands, he should able to catch two gadgets, two objects. Okay, so what I did first you come with one thing. Okay, first he came here. I checked his current molecules in his hand. I came to know he has a one pen. Okay, so currently I know he has one value. Okay, then what I did is I removed this pen from his hand and I given him 4 objects. You need to catch only one object per hand. I given 4 objects to him. Okay, I know the value, that is 4 objects I given. Okay, then I did a certification. I removed the excess things. Then I'm going to calculate. I did again the test of how many molecules he has. He given me 2. So this means the total capacity of Keshav is 2. How I measured this 2? By measuring the initial thing. Okay, 2 minus initial value will be the total capacity. If he has 4 hands, then I might get 4 minus my given step. I give 10 minus the current value 4. That will be his total iron binding capacity. This is what we did. So first what I did, I removed his current iron molecule. Right? How I removed means I threw some acid on his face. So he he threw it. Okay. So that is how I removed his entire hands from the molecules, from transferrin molecule. Okay. Is this clear?
Sir, obviously, sir,
Yes, I given a known value to the completely removed protein.
Yes, sir.
Now, after giving my known value to it, I waited for some time, let it take my molecules. Then this is called incubation. Then I did a wash step. In washing, what happened? Complete molecules has been binded. That is the theory states. It should bind. And whatever leftover will be there in the circulation, I washed it. That leftover molecules has been removed. So now I am measuring total value, total given value minus current measured value. Current measured value is 150. Okay, 150 minus 200. 50. Yeah, that's it. So 50 will be the TIBC. That is how we got 250 to 400 range. Okay, that's it. Now is their values. Okay, so all this test is based on colorimetric principle. Tell me what is colorimetric? B of color is directly proportional to the concentration of substance present in a colored solution. Right? If I have 10 grams of turmeric powder, I will get a deep yellow color. If I have 1 gram of turmeric powder, I will get a pale yellow color. Color is directly proportional to the grams of turmeric powder. Clear? So here we are measuring the color of the solution before and after. Okay. So what values you will take in colorimeter? Tell me, students. So yeah, write down this value. Iron in microgram per deciliter is equal to OD of test minus
OD of blank.
OD of blank plus OD. Okay, listen. I'm taking two types of blank here. Standard blank and blank. Okay, water blank is blank. Standard blank is standard actually. That is also called standard blank. Okay, standard blank minus blank by this is into 100 by OD of standard minus OD of blank. This will give me the total iron binding capacity. So the same formula we will use two times. Step 1 and step 2. In step 1, okay, I didn't add acid. In step 1, I didn't add acid. I took the iron value. Serum iron value I got in the first step. Then in the second step, I added acid. Then I added a buffer and I incubated it. Okay, a known value, a known buffer I added. I incubated it. Phosphate buffer I added. I incubated it. Then I took the second value. This is a TIBC value. Second value minus first value will give the TIBC value. Okay. Second value minus first value will give me the TIBC value, total iron binding capacity test. Now there will be many technical terms from test to test. What are the names of buffers? There are various buffers. Okay, saturating reagent, precipitating reagent, iron reagent, distilled water, buffers. So all these things will have same components from kit to kit. They will have some acids. Okay, okay, I will give you the reaction. The reaction will be like this. Write down the reaction. So ferrous Fe3 plus has been converted to Fe2 plus in an acidic medium. Okay, 3 plus released iron to ferric status. This is ferric status, ferrous status. Okay. Now this ferric ion will react with a molecule to get a color. That enzyme will be ferrozine. Ferrozine reacted and we will get a violet color complex. The amount of color is directly proportional to iron in the body. We are measuring iron to measure indirectly the TIBC. I mean indirectly the transferrin status. This test itself is an indirect test actually. We are not detecting the protein directly. Rather than we are detecting the iron to know the protein status. Got my point?
Yes, sir.
Sir, we are detecting iron, right? We are detecting iron.
Iron.
In this test we are detecting iron
Binding.
for the purpose of understanding the transferrin binding capacity.
Sir, bounded iron or unbounded iron?
Binding iron.
That depends. That can be anything.
Total iron binding capacity means
Yes.
binding.
Yeah, stop it. Apart from TIBC, you recording again? Ah yes. Apart from TIBC, you just tell me some normal things, students. Differential diagnosis. Differential diagnosis means what other tests you will do to confirm this issue. Differential diagnosis. Okay. What other non-hematological tests you will perform to know this TIBC level? Yes, tell me.
Complete blood.
In CBC, you will take, give me a specific test parameter
Sir.
to indirectly measure the iron deficiency in the body.
Sir, we can perform ESR.
HB estimation.
HB, okay. HB estimation, not ESR. ESR is different.
Okay,
story. That's
sir,
called viscosity.
The solubility test.
Solubility, any more specific?
Signaling test.
A cycling hemolysis test you are saying, okay. Hemolysis test you can do. More specific CBC test. MCH,
Mean corpuscle level.
okay, and MCV. You can do these two tests to cross verify TIBC status. Okay, here these two tests must get low values. If TIBC is less, that should cross relate with these two values. Let me see. When there is a hemolysis, yes, that means that you will also confirm with TRBC, total red blood cell count in the body. So this is the differential diagnosis to detect the TIBC. So why this test is important? Why this test is important? Listen, I want to know how many, why I am checking the total binding capacity in patient. The reason is, I am getting a call from Chandigarh University. Okay, we'll see later. Okay, see, no ORM issues. Somewhere I'm commenting, they're thinking I'm taking an admission. So many times this happens. Then I said I'm faculty. Then they again saying, are you taking admission? I am teacher. I'm trying to check the binding capacity of the iron binding. This is very useful among frequent blood transfusion patients. Like someone has a sickle cell or some hemolytic disease and they are taking frequently blood transfusion. Whenever they are taking blood transfusion, there is a chance of hemolysis in the body. Every transfusion will induce a hemolysis in the body. And is my patient Transferrin can able to hold the iron stress? When there is a hemolysis, can my patient's iron binding protein can able to compensate the issue? Or is he going to die because of iron toxicity? Whether my patient has a sufficient protein molecules to remove the overload from the circulation. For that purpose we are doing this test, and this is also important for dialysis patients. When a frequent dialysis patient, okay, more hemolysis can happen, so we will check the TIBC value in dialysis patients. Okay, now tell me, TIBC will be reduced in hemolytic conditions and it will be more in iron deficiency. Okay, more TIBC is okay, less TIBC is dangerous.
But sir, if a patient take a iron intake diet more,
What if patient taking more iron intake?
or only iron intake diet? For example, sir, in the supplements we having iron.
Yeah, okay, patient taking more iron. So now constantly iron was loading there, and his TIBC is less. Then that will be a complication. More iron, less protein. Ideally, what should happen? That's why this is not about
Iron.
this and this. We are checking only this protein.
Okay, sir.
How much protein it is available in the circulation.
Okay, sir.
Okay. It's not like that this is directly proportional to this protein. It's not that. It's not about iron directly proportional to protein. That because protein is always constant. Okay. Yeah. The free protein will be less, and it cannot take the stress of iron. What's my point? When there is bounded with iron to transfer, so there is a less protein availability.
सर तो ये प्रोटीन प्रोड्यूस नहीं होता बॉडी में?
Yeah, there is a limit to the protein production. there is a problem with this, okay? Because our body don't have a iron eliminating system in the body. You remember? So we need to compensate with the available protein. Now listen, this test will be important for liver disorders also. When there is a liver issue, protein will be less. Iron toxicity can kill the patient.
सर तो जैसे अब अगर हमारी आयरन ज़्यादा है और प्रोटीन कम है तो हमने क्या लिखना है कि आयरन हमारा कम होगा या ज़्यादा होगा?
What iron you are checking first? Is it a serum iron? Is it a bounded iron or is it a free iron? You need to cross verify that with the bounded iron and free iron.
And sir, we are checking the bounded iron in this test.
What we are measuring the patient sample? Are we measuring bounded iron or a free iron? That I will know.
Sir, in this test we are checking the bounded one.
In this test we are checking the serum iron. That means the serum bounded iron. And your question is, the patient has capacity of the body to take care of the iron. Yeah. So this test is about the capacity issues of the patient, not about the status of iron in the patient. Status of iron is different from capacity. Even though if patient has more iron, a normal iron, we need to check the TIBC. If TIBC coming normal, that's okay. When the TIBC drop, that indicates a problem.